Well, the only resistor that measured substantially different from the marked value is the one down there that you see a little bit on the left. It's called R6 on here. You see it on this schematic right here, or this parts layout, R6 right next to L6. And it only measures a couple of ohms, and the reason is that, and here's something that you do need to watch out for when you're measuring. You see there's R6, and it's across the winding of the oscillator coil, and you notice next to it it says 3 ohms. And so the 3 ohms that is marked there is of course going to shunt that 10K, and that's about what it read, was just a little over 3 ohms. So whenever you find a value that seems out of tolerance, the first thing to do is check the markings on the resistor. The second thing is to check the schematic to see if there's something in parallel. And then of course, if you still feel that the value is wrong, well, you can always disconnect one end, because if you're going to have to replace it, you're going to have to disconnect one end anyway. So anyway, I finished doing all of the resistors in here. I also checked coils while I was at it. So the next thing to do is to move on to doing a little bit of alignment. And there I thought I might mention just one more thing about equipment. Honestly, you can do almost anything you need to with just that little multimeter. The one exception is if you're going to do alignment, you need something that can generate RF signals. Now there's a signal generator. I bought that new, but way back in the 70s. It was one of the first transistorized signal generators. Before that, I had a tube version that is out in the garage right now. But the nice thing about having a signal generator is not only can you use it to align the stages, but you also can use it to basically do what's called signal injection. That is to find problems in the radio. And in the next little segment, I'm going to talk about that a little bit, and how you can kind of look at one of these radios and break it into 4 blocks. Okay, what I've done here is I've taped together 2 pages so that we can see the continuous schematic. And then I've drawn on it the 4 blocks that I told you earlier. Now, every radio can be broken into these 4 blocks. Or I should say every super heterodyne radio can be broken into these 4 blocks. The first block is called the RF, and that is where the signal comes in, whether it's AM or FM, whether it's 1,000 kilohertz or 100 megahertz, it still comes in as RF. The purpose of the RF stage is to clean up the signal, separate it, maybe amplify it, and then convert it to the IF. That's the intermediate frequency. So the next stage is the IF stage, and every super heterodyne has an IF stage. Maybe 1 tube or 2 tubes or 5 tubes, depending on how good the radio is, but basically the purpose is to amplify the signal at the intermediate frequency after it's been converted from RF down to IF. Once it comes out of the IF section, it has to come through a detector. A detector is something that removes the IF carrier and converts the signal to audio frequency, or AF. Now, in this case, I've drawn the line over here. It actually goes right through the middle of this tube, because as you probably can see here, this is the AM detector and first audio. So on the left side over here, you have IF, and on the right side you have AF. And the place that you can find that's always the connection between the IF and the AF is the volume control. Notice the center tap, or the wiper of the volume control, is always the place where you find audio frequency AF from there on to the speaker. And so of course then the purpose of the AF is to amplify that signal up to something loud enough to drive the speaker. There is actually one more conversion that occurs in the speaker. A lot of people don't think about that, but it converts it from electrical signal to an actual acoustic signal. In other words, a sound wave in the air. And then finally, there's the power section, which usually includes the power for the filaments as well as some kind of rectifier. It can be half wave, full wave, bridge. It can be a tube. It can be a selenium or silicon rectifier, and so on. Basically, the purpose of that, of course, is to produce the B+. And in this case, the B+ is 120 volts. So, if you can separate your schematic into these 4 blocks, you can isolate any problem down to one of these blocks. The way you do that is with signal injection. For example, if you inject an audio signal at the wiper of the volume control right here, you should get a signal out of the speaker. If you don't, something's wrong with the audio frequency, or AF section. Could be the speaker, could be the tube, could be the transformer, but basically you only have to work in this part of the schematic. Similarly, if you inject, once you know the AF section is working, and you inject an IF signal into the IF section, you should also get something out of the speaker. If you don't, and you know the AF is working, then it has to be the IF or the detector. Finally, same thing is true of the RF. If you inject an RF signal into the radio, you should get a signal out. And if you don't, and you know that the IF and AF are working, then it has to be the RF section. And last, of course, the power. You can check easily to determine if you do or don't have B+, and whether the filaments are lit. Okay, the next thing we're going to do is we're going to show how, with just a signal generator and a multimeter, you can test an entire radio. The first check, of course, is to make sure you've got power, which in the case of this particular set is 120 volts. It's supposed to be on the red lead there going into that transformer, and of course it goes other places as well. So the first test that we'll do, we got our multimeter set up to measure DC voltage, and we'll come in here and measure that. Reads 120.3 volts, so that's pretty close. The next thing is, I like to sort of split the problem into 2 halves instead of trying to test all 3. And that is, set your signal generator for about 455 kilohertz, which is there on band B. See over here, it's set on band B, and I've got the output set to high, and the attenuator, the fine adjustment, set to about the middle of the range. And now here is all you really need to do to test an AM radio. You just put it near, in this case, the loop antenna, and you hear the 1,000 cycles. In other words, you don't even need to make a connection to the circuit. Now let's switch over to 400 cycles, and we'll be able to hear the difference. Now, that tells us that everything from the IF through the AF is working. If we hadn't gotten a signal, the next thing we would have done is we would have gone to the center tap or the wiper of the volume control, and we would have injected audio frequency signals. That in the case of this generator, they come out there, and you adjust the volume over here. Now, in this particular set, because it's a printed circuit, the volume control is a little hard to see in this position, but it's right in there. And the wiper, of course, comes through the printed circuit board on this side. Let's see if we can find it. It's that it's right there, those three terminals. Well, the camera's not cooperating too well, but at any rate, if you needed to, you can find the volume control and then locate the center tap or the wiper and apply an audio signal. In our case, we don't need to do that, but the next check is to apply an RF signal. And so up here, I'm going to go to, well, I think what I'm going to do is just leave it on band B. I'm going to put this over here. Go back to 1,000 cycles. Now, what we're going to do is we're going to tune up. I don't know where the dial is set, but actually I do know where it's set. It's set on 590. And you see it's reading about 582 or 583 on band B. So now what we have verified is that the converter, which in this case it's the AM converter, right there is working. That's 12AU6. So we know the converter is working. The signal is coming in from the loop antenna and being converted to the IF, and then flowing through the IF, being detected by the AM detector. Amplified by the first audio, then by the audio output, and eventually is coming out as sound waves from the loudspeaker. So, with just, in this case, 3 tests, you can verify that the radio is working. Now, that doesn't mean that it's necessarily aligned, and so that's another thing we're going to have to do, is check the alignment. But once again, we'll use that same piece of equipment. So my point really is that with just that signal generator and that multimeter is really all the electronic test equipment you need to work on these radios. You can do voltage and resistance checks, both AC and DC voltage, resistance checks. You can also do some testing of capacitors, and some of these modern multimeters even have a capacitance range. This one does. So you can check the value of a capacitor. Now that doesn't fully test it. As you probably know, the voltages in these sets can be pretty high. This particular set, remember, is 120 volts, but on some of the other older sets, the voltages could run 350, 400 volts. And of course, this meter runs on a little 9-volt battery, so there's no way it can test a 450 volt capacitor at its limit for leakage or whatever. But that's the point of replacing all of those. Anything that's questionable, you don't have to buy an expensive piece of test equipment like this one up here that will test capacitors at those high voltages. Instead, just replace the electrolytics and the papers. And with that, and a few simple checks, some voltage readings, and a signal generator for injection and alignment, you can get a radio working in very little time. So don't be intimidated by what looks like complexity. Break the schematic up into blocks, check each block in a kind of macro way, and then if you find that, for example, the IF isn't working, but the AF is, well, then you know where to concentrate your voltage and resistance checks until you find the problem. Well, I'm going to call it quits on this video for now, mainly because I'm going to be doing some quite different thing when I start the alignment, and that'll be an entirely different set of videos. I'll be doing both AM and FM alignment and show you at least how I do it, and hopefully you'll be able to learn from that as well. So bye for now, and we'll be talking some more in the future video.